Scientists can analyse the outmost layers of materials, such as metals, glass, semiconductors and ceramics, to determine their chemical composition and molecular structure. This is known as surface analysis, and it is useful for improving manufacturing technologies, quality control and research. The instruments required for surface analysis can be too costly for one group to purchase and run alone, so pooling resources is vital. The instruments are then used across a range of research groups, and as they cannot be moved, researchers have typically had to travel to the instruments in order to use them. This is taxing in terms of time and money and creates difficulties in transporting data back to the home institutions, while it also creates a bottleneck of users. VeRSI is the Victorian eResearch Strategic Initiative and is working with researchers at Trobe University's Centre for Materials and Surface Science to overcome the issues associated with large-scale collaboration. The Centre for Materials and Surface Science is interested in making and exploring new materials using a whole range of instruments and techniques.
At La Trobe we've got a very broad range of surface analytical instrumentation. We've got two state-of-the-art X-ray photoelectron spectrometers. So these are commonly called XPS instruments, and they examine the outermost 5 nanometers of the sample surface. We also have a TOF-SIMS machine, and a TOF-SIMS is a surface mass spectrometry, which allows you to make a mass spectrum from the outermost layer of molecules at the surface.
The Centre shares these tools between 25 universities worldwide, as well as 40 companies and several large external research organisations. In order to make collaboration easier and remote access possible, VeRSI has undertaken the Remote Laboratory Instrumentation Project, or RLI. The RLI involves building secure and robust web-based interfaces to the instruments so that they can be used by external clients, as well as geographically remote researchers, to conduct experiments over the internet.
Often people will come directly to the lab and work with us here, but we see the e-research direction as allowing people to interact in a more complex fashion without having to actually come to our site here. What we're trying to achieve is an immersive experience. We want people to be able to communicate face-to-face using the high-definition video conferencing so that they can understand what the other side is doing and really get that emotional involvement in the analysis task. They can see people moving around the lab, they can see people loading their samples, they can see the instrument working to do the analysis. So you get a more comprehensive picture of what's happening at that remote site, not just face-to-face talking.
Other benefits include the protection of the instruments from unauthorised access, as well as facilitating data management, instrument control and access management. Future engagements between the Centre and VeRSI involve building a visualisation lab where students will be able to utilise the lab instruments within a classroom setting. The lab will also further enable remote collaboration with the Australian synchrotron and will encourage the integration of new technologies into basic research training.
For us, we want to be known as world leaders in surface science. We have wonderful resources, excellent research projects and wide collaborations. The RLI project is going to allow us to project our abilities and our laboratory to a whole range of people, not just in Melbourne but around Australia and around the world.
Through these facilities and tools, VeRSI is enabling collaboration as well as supporting more efficient research outcomes.